Hi, this is Yogananda. Today we will be discussing about DB scan. So DB scan, it is also known as density based spatial clustering of applications with noise. So it is an unsupervised machine learning technique which sometimes works better than k-means clustering and hierarchical clustering. So why we would use DB scan? So for example, now imagine we collected weight and height measurements from a bunch of people, and we plotted the people on a two-dimensional graph like this, where we have weight on x-axis, first dimension, and height on the y-axis, which is second dimension. By eye we can see we have two different clusters, green and blue, which are densely populated. On the other hand, we can see these remote clusters, remote points, so which are known as outliers. So these are basically outliers. So by clustering, this data is pretty easy. However, because these clusters are nested, meaning we can see these clusters are nested. So however, because these clusters are nested, meaning the green cluster wraps around the blue cluster, so a relatively standard clustering method like k-means clustering might have difficulty identifying these two clusters. So what happens is that instead, because of the nestings, a simple clustering method might get something weird like this. So we can see here that this group of points are actually classified into blue color, but actually they belong to the green color. So this is what happens when we use a simple clustering algorithm like k-means. So we need a clustering algorithm that can handle this nested clusters. Also, we need so we can see that this is a two-dimensional graph, so which uses only weight and height data. But if we wanted to include another feature, which is a new feature like person's age, so we would have to add a third axis, and the now graph is three-dimensional. But if we have four or more features, we would need to draw four or more dimensional graph, and that's not possible. And if we can't draw and look at four or more dimensional graph, then we need a way to identify these nested clusters that are we cannot see by eye. So the good news is that there are clustering algorithms that can identify nested clusters in high dimensions, and dbScan is one of them. So dbScan, it actually works like based on set of points. Let's think in a two-dimensional graph as seen before. So dbScan groups together points that are close to each other on a distance measurement. Usually we assume the Euclidean distance as a default one, and the minimum number of points, it also marks as the outliers. So as we have seen, there were some points which were considered to be remote, so this would be the outliers. So coming to pa parameters and classification. So the dbScan algorithm basically requires two parameters. So the first one is epsilon, so which specifies how close points should be to each other to be considered a part of cluster. It means that if the distance between 2 points is lower or equal to this value, which is epsilon value, then those 2 points are considered neighbors. And next, coming to the other component, which is minimum points. So it says that the minimum number of points to form a dense region. For example, if we set the minimum points parameter as 5, then we need at least 5 points to form a dense region. So the classification of points in dbScan algorithm are core points, border points, and noise points. So let's understand all these components with the help of a figure. So coming to this figure, so let's consider some initial points as shown in the figure. So these are the points. Initially, we consider some epsilon value and some epsilon random value, and let's consider some minimum points value, which is 4. So it depends on the distance basically. So when coming to the first component, which is the epsilon. So suppose this is a point which has, suppose let's consider this point which is C. So this point actually has a radius as epsilon naught. So we will be uh, This epsilon value is 3, let's assume, and we create a circular boundary across it in such a way. The next component is minimum points. So in this case, we have minimum points as 4. For suppose if we have 4 points like 1, 2, 3, 4 across this boundary, inside this circular boundary, we have 4 points. So in this case, we consider the point C to be a core point because it has got 4 points, which is the minimum points value 4. It has 4 points inside this circular boundary with the radius as epsilon value. So this point C is considered to be a core point. So the next component, so let us consider a point A. So let us consider a point A. So it has a radius of epsilon, and let us assume the circular boundary across it. Okay, so this is the radius. For example, it does not satisfy the conditions which is 4 points. So this circular boundary doesn't have any 4 points, but it does have a core point inside this. So we are the condition is it doesn't have minimum points as 4, but it does have a core point inside the circular boundary. Then this point A is said to be a border point. Next, if we consider another point D, sorry for this, yeah, this is a point D, and let us assume it has a radius, so it has got the radius as epsilon value, and for this point D, it has no it has no core point inside it, and it doesn't satisfy the condition minimum points for. So there are no point. It doesn't satisfy the condition for, which means that there are no 4 points inside this, and it has got no core point. So this would be the point D would be considered as a noise point. So noise point is basically an outlier. So dbScan nicely handles this outliers. So which basically means that whenever dbScan discovers any noise points, so it will be considered as an outlier. It will never draw the circular boundary across it. It will skip that point and never treat it as a part of a cluster. But coming to the case of core and border points, it will be considered circular boundaries across it and treating it as a treating it as a cluster. So as you can see that, let us assume this circular path, circular boundary. So let us assume this is the point A. So it has got 4 points inside of this circle. So this point is said to be a core point. But for example, if we take this point, which is point D, if we take a specific radius for this and draw a circular path across it, we can see that there is only one core point inside this circular boundary, and it doesn't satisfy the minimum points condition. So this point would be said to be a border point. But coming to this case, if you see, this is a noise point. So it doesn't satisfy the condition of minimum points and doesn't have a core point inside it. So it is said to be border point. So next we can see that the dbScan algorithm. So it labels all points as core, border, and noise points, eliminates noise points, and put an edge between all core points that are within epsilon of each other. Make each group of connected core points into separate cluster. Assign each border point into one of the cluster of its associate core point. And coming to parameter estimation, so we see that epsilon value is chosen to be too small. It shouldn't be too small or too big. It should be based upon the distance of the data set. In general, we assume epsilon value to be preferable to be small. I mean, my points, it depends upon the dimension. There are usually better data with noise for more significant clusters. The minimum value for minimum point should be 3, but larger data set, larger the minimum point should be chosen. And next, what are the advantages and disadvantages? As we have seen, it is great at separating clusters at high density. And the disadvantages is that it does not work with the varying clusters of density with high dimensions. That's all we have today. Thank you very much.